National Electrical Code Article 240.15b2 states that feeders shall be permitted to be tapped to supply branch circuits for small motors. Taps shall not be made to the ungrounded conductors. In this context, a dryer outlet can be considered a branch circuit for a small motor, specifically the motor that turns the dryer drum. Therefore, this exception could apply, potentially permitting you to tap the main connections to the fuse panel for this purpose. It's critical to understand the limitations and requirements associated with this exception. You must ensure that the dryer is indeed considered a small motor application within the interpretation of the local authority having jurisdiction and the NEC itself. National Electrical Code Article 240.15b3 states that feeds for ranges and wall-mounted ovens shall be permitted to be tapped from the service entrance conductors outside the panel board. Taps shall not be made to the ungrounded conductors. This exception specifically addresses ranges and wall-mounted ovens. While it doesn't explicitly mention dryers, it's sometimes interpreted as allowing similar taps for other heavy appliances. The reasoning behind this interpretation is that dryers, like ranges and ovens, are significant electrical loads. However, it's crucial to verify this interpretation with the local authority having jurisdiction, as interpretations can vary. Based on these National Electrical Code articles, specifically 240.15b2 and the interpretation of 240.15b3, adding a two-circuit panel for two-pole breaker and tapping the main connections to the fuse panel might be acceptable. The understanding is that these taps will primarily carry the dryer load. It is essential that all work is carried out by a qualified electrician familiar with local codes and regulations. It is also very important to remember a few additional considerations. Firstly, the wire used for the taps must be of the correct size to safely carry the dry load. Consult National Electrical Code tables such as Table 310.16 to determine the appropriate wire size based on the ampacity requirements of the dryer. Remember to account for voltage drop, which can affect the performance and safety of the circuit. Secondly, the taps must be made in a workmanlike manner using approved connectors. Ensure that the connectors are properly rated for the wire size and material being used. Follow manufacturer's instructions carefully to ensure a secure and reliable connection. Avoid using methods that could damage the conductors or create a fire hazard. Thirdly, the panel added for the dry circuit must be of the same voltage rating as the fuse panel. This is crucial to prevent damage to equipment and ensure safety. Verify the voltage rating of the existing fuse panel and select a new panel with a compatible rating. Using a panel with an incorrect voltage rating could create a dangerous situation. Also, always check local requirements for permits. A permit may be required for this electrical work in your area. Contact your local building department or electrical inspector to determine whether a permit is necessary. Obtaining a permit ensures that the work will be inspected and complies with local codes. It's important to emphasize the significance of consulting the local authority having jurisdiction, often the electrical inspector, before undertaking any electrical work. Their interpretation of the National Electrical Code and local amendments will be the final authority on whether the proposed installation meets code requirements. The National Electrical Code is a comprehensive set of guidelines for electrical installations, but its application can vary depending on local interpretations and amendments. Always seek clarification from the local authority having jurisdiction to ensure compliance. Additionally, the suggestion to tap the main connections of the fuse panel to supply a new subpole requires careful consideration of the existing electrical service capacity. Before proceeding, it's essential to perform a load calculation to determine whether the existing service can handle the additional load of the dryer circuit. The National Electrical Code provides guidelines for load calculations in Article 220. This calculation should take into account all the existing loads in the service, as well as the anticipated load of the new dryer circuit. If the load calculation indicates that the existing service is not adequate, upgrading the service may be necessary. Overloading the electrical service can lead to overheating, voltage drops, and potentially fire hazards. Furthermore, when tapping the main connections of the fuse panel, it's crucial to ensure that the tap conductors are properly protected by an overcurrent device. The overcurrent device, typically a circuit breaker or fuse, should be sized to protect the tap conductors and the downstream circuit. The size of the overcurrent device should be determined based on the ampacity of the tap conductors and the requirements of the National Electrical Code. Improperly sized overcurrent protection can lead to conductor overheating and potential fire hazards. Moreover, the physical installation of the tap conductors should be performed in a neat and workmanlike manner. The conductors should be properly supported and secured to prevent strain on the connections. Avoid running the conductors through areas where they could be subject to physical damage. Use appropriate wiring methods, such as conduit or cable, to protect the conductors from damage. A well-executed installation not only ensures safety but also facilitates future maintenance and troubleshooting. The condition of the existing fuse panel should also be carefully evaluated before proceeding with any modifications. If the fuse panel is old, damaged, or shows signs of overheating, it may be necessary to replace it entirely. Attempting to tap into a deteriorated fuse panel can be risky and may compromise the safety of the electrical system. A qualified electrician can assess the condition of the fuse panel and recommend appropriate repairs or replacements. Replacing an outdated or damaged fuse panel can improve the safety and reliability of the electrical system. It's important to also consider the labeling requirements for the new subpole and the tap conductors. The National Electrical Code requires that all electrical panels and circuits be properly labeled to indicate their purpose and voltage. Clear and accurate labeling helps to prevent confusion and facilitates future maintenance and troubleshooting. The tap conductors should be labeled to indicate that they supply the new subpanel. The new subpanel should be labeled to identify the circuits it serves, including the dryer circuit. Proper labeling is essential for maintaining a safe and organized electrical system. In addition to the technical considerations, it's also important to communicate effectively with the homeowner about the proposed modifications. Explain the scope of the work, the potential benefits, and any potential risks. Answer any questions the homeowner may have and address any concerns they may raise. Providing clear and concise information can help to build trust and ensure that the homeowner is fully informed about the electrical work being performed. Open communication is essential for a successful and safe electrical project. Remember that electrical work can be dangerous and should only be performed by qualified and experienced individuals. If you are not comfortable working with electricity, it's best to hire a licensed electrician to perform the work. A qualified electrician has the knowledge, skills, and tools necessary to safely and correctly install electrical systems. Hiring a licensed electrician can provide peace of mind and ensure that the electrical work is performed in compliance with the National Electrical Code and local regulations. Safety should always be the top priority when working with electricity. Double-check local requirements with your local authority having jurisdiction. Remember, the National Electrical Code is updated regularly. Ensure you are referencing the most current edition. The National Fire Protection Association publishes the National Electrical Code. It is widely adopted in the United States and serves as a benchmark for safe electrical installations. Local jurisdictions may adopt the National Electrical Code with amendments to suit local needs and conditions. Always refer to the latest edition of the National Electrical Code and any applicable local amendments. Consider the impact of the modification on other electrical systems within the dwelling. Ensure that the proposed changes do not adversely affect the performance or safety of other circuits or equipment. For example, adding a new load to an existing circuit may cause overloading or voltage drops. Assess the potential impact on other systems and take appropriate measures to mitigate any negative effects. A comprehensive understanding of the entire electrical system is essential for ensuring safety and reliability. The importance of documentation cannot be overstated. Maintain accurate records of all electrical work performed, including wiring diagrams, load calculations, and inspection reports. This documentation can be valuable for future maintenance, troubleshooting, and modifications. Store the documentation in a safe and accessible location. Proper documentation is an essential part of responsible electrical work. It's important to consider the long-term implications of the proposed modification. Will the new sub-panel meet the future needs of the homeowner? Is there room for expansion if additional circuits are needed in the future? Planning for future needs can help to avoid costly and disruptive modifications down the road. Take a proactive approach to electrical planning and consider the long-term implications of any changes. Prioritize energy efficiency when selecting electrical equipment and designing electrical systems. Use energy-efficient appliances, lighting, and controls to reduce energy consumption and lower utility bills. Install occupancy sensors to automatically turn off lights in unoccupied areas. Use dimmers to adjust lighting levels and save energy. Energy-efficient electrical systems not only save money but also reduce environmental impact. Stay informed about new technologies and best practices in the electrical industry. Attend training courses, read trade publications, and network with other professionals to stay up to date on the latest development. Continuous learning is essential for maintaining competence and providing high-quality electrical services. Invest in your professional development and stay at the forefront of the electrical industry. Adhere to the highest ethical standards in all your electrical work. Be honest, fair, and transparent in your dealings with clients and colleagues. Uphold the integrity of the electrical profession and always prioritize safety and quality. Ethical conduct is essential for building trust and maintaining a positive reputation. Remember that electrical safety is everyone's responsibility. Take precautions to protect yourself, your clients, and the public from electrical hazards. Follow safe work practices, use appropriate personal protective equipment, and never take shortcuts that could compromise safety. Electrical safety is a shared responsibility that requires vigilance and attention to detail. The installation must comply with all applicable codes and regulations. The NEC provides a comprehensive set of standards for electrical installations, but local codes may impose additional requirements. Verify compliance with all applicable codes and regulations to ensure a safe and legal installation. Non-compliance with codes can result in fines, penalties, and potential safety hazards. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts are at the same potential. Improper grounding and bonding can create shock hazards and increase the risk of electrical fires. Follow the NEC requirements for grounding and bonding to ensure a safe electrical system. Surge protection can help to protect sensitive electronic equipment from damage caused by voltage surges. Install surge protective devices at the service entrance and at individual branch circuits to protect against both external and internal surges. Surge protection is an important part of a comprehensive electrical safety plan. Arc fault circuit interrupters provide enhanced protection against electrical fires caused by arcing faults. ASIs detect arcing faults and quickly energize the circuit, preventing fires from starting. The NEC requires ASIs in many areas of the home, including bedrooms and living rooms. ASIs are an important safety device that can help to protect your home and family. Ground fault circuit interrupters provide protection against electric shock by detecting ground faults. GFCIs quickly de-energize the circuit when a ground fault is detected, preventing serious injury or death. The NEC requires GFCIs in many areas of the home, including bathrooms, kitchens, and outdoor locations. GFCIs are an essential safety device that can help to protect you from electric shock. Electrical inspections are an important part of the construction process. Electrical inspectors verify that electrical installations comply with the NEC and local codes. Schedule an electrical inspection to ensure that your electrical work is safe and code compliant. Electrical inspections can help to identify potential problems before they become safety hazards.